Twitter sent out. Get the bot in here. Man, I really hate the new Twitter layout. It's quite bad. And let's get our Discord taken care of. All right. Hello, everyone. This is Chris Ingerson, and it is, I was going to say January for some reason, but it is not January. It is July 25th, and this is the July 25th Text Quest Devstream. So, today, I'm going to check if my audio is the, today we are going to be finishing up our spawning for the wood sections, and then we're going to be moving on to trying to get the fog in the woods to behave in a way that makes it less apparent that you are teleporting. So we need to basically, I want to have fog particles that obviously say the word fog. Um, but if I use a particle system, I need to make sure that when you teleport or when you get warped to seamlessly wrap, that um, you will essentially not notice a sudden jump in the positions of the particles. So we're going to need to try to come up with a way that would basically allow us to um, have the fog particles be seamless across movements. There are a couple of ideas that I have. The main one that I think we're going to stick to is going to be based on manipulating the random seed of all of the um, particle systems, basically, or rather, each section will have its own particle system, and we're going to try to sync the random seed of the particle system. That way, they should, in theory, have the exact same particle outputs. I'm hopefully not going to have to do anything beyond that. If it doesn't work, we're going to probably end up having to look at some sort of like manual spawning of particles across all of the possible um, sections, which is going to suck. But to give you a sense of where we are currently, actually, I should probably go ahead and fix my textures first because we're going to be all blue right now. I'll just go ahead and run up. So currently, if we despawn a section and then we try to go back, that section is just not in the dictionary for our list of existing sections. So you'll notice this is pointing to to Woods Layout New, line 316, which is right down here, basically right here. It is very impressive that this is happening because if you look at this call, what it's doing, it's basically looking for a section that is currently inhabited, which means that for some reason it doesn't think that a section that you are currently residing in exists, which is highly unlikely. That is a very weird thing for it to do. Actually, hold on. Inhabited sections. Oh, wow. Right there. That might be it. Why was I doing that? Why on earth was I doing that? Okay, well, that might have been my problem right there. Of course, I spend a decent chunk of time trying to solve it before the dev stream tonight, and then it's like, possibly solved in the first 5 seconds. So, that'll be fun, if that's the case. It'll just be embarrassing. And that embarrassment will be recorded for all to see. So, well, assuming that fixes that problem, actually, which I have no idea, again, why I did that. Because there's no reason for me to despawn to remove the current section from the list of sections. That's very odd. Despawn section will do that for us at the bottom here. Super weird. Alright. Let's go ahead and clear that. I am going to go ahead and select my couple of my objects here so that we can force them all to render everything. Hilarious. The fog settings for the scene affect the preview. You're just the worst. Alright, let's go all the way down here. We're going to do this, because I have to do this all the time. Boop. That. Force you to update. Get rid of you. Second here. Alright, so that should, for the most part, have fixed everything. A couple of things to make sure that everything looks correct. Oh yes, the tree wall. Okay, now we should probably have everything in there. Alright. We're just going to go ahead and save that. Let's hit play. Let's give this a shot. Man, I wish I knew why my thing did that. So you might notice that occasionally my app seems to freeze. It doesn't have anything to do with the app itself freezing. It seems more like Windows is basically forcing it to not update. Because occasionally the window basically becomes deselected, but the X button becomes highlighted. It's very strange, and it's fixed as soon as I move my mouse, but I have no idea what causes it. Anywho. Oh, look at that. It's working. Just fine. Okay. Let's go ahead and keep moving over here. That is troubling. I am not sure why it did not despawn you. Is it just not it's not despawning the immediate sections, which is interesting. So it doesn't despawn the sections that are immediately after the warp point. Right there. I'm not entirely sure why that's the case. It's a minor enough issue that I'm not too worried about it for now, but it is something that obviously needs to be fixed at some point. Those teleport points are clearly messed up. Just kind of have fun here. Oh. How interesting. All right. I'm guessing that's just because the settings are not set up properly for those. That's fine. All right. So the next thing that we want to do is handle fog. I'm going to look at cleaning up those teleportation sections a little bit later. So the idea that I have is basically that we would set, and actually, you know what, I'm going to go ahead and do a quick test run here. Let's layout test. So I'm going to turn this off. Hero is at 0, 0, 0, which is where it should be. I'm going to go ahead and just dump a quick quad in here. Not UI, quad. Okay, we're just going to rotate this 90 degrees. We'll scale this up by 5, by 5, by 5. And then it's got a mesh collider. That's all fine. Zero this out. We'll just put this at like -0.01. So it's slightly, we'll do -0.1. So it's slightly below the spawn point. That means that we should just basically drop in, stand on top of it. And I'm just going to put 2 test sections together in front of us, and we're going to see if we can set up fog particles in a way that will cause them to properly function. So I'm going to go ahead and pull in, let's go ahead and grab sections. I'm going to pull in a grass section, and then I'm also going to pull in, I'm going to do a couple of things. I'm going to turn on snapping, and then I'm also going to go ahead and pull in, I don't know, path in down. Sure, why not? All right, so we're going to move this up to here, move this to here, move this up to here, move this over to here. We're going to try to position these roughly centered a little bit so that I can properly see everything. Okay. Actually, no, I don't want to make this path end left. Let's do path end right then. Okay. There we have a very obvious demarcation of the halfway point. So with that, I'm now going to do I'm going to basically apply new particle effects here. So we're going to create effects, particle system. We are going to change a couple of things. Default particle, this is going to be fog. Okay. Instead of being, let's see here. Shape's not going to be a cone. It is instead going to be a box. It is going to be, let's see here. We don't want them to have any velocity. Velocity, which should be up here. So start speed's going to be 0, actually. We do want them to have color over lifetime. I'm going to go ahead and turn that on. We're going to give these, oops, that's the color. I don't actually want that. I'm going to give it a couple of alpha points. So it's going to be 0 to start. We'll have you fade in at like 10. Have you be down by 90. Have you fade all the way back out again. So basically things should be fading in and out as we see fit. Let's go ahead and scale up our volume. So it should be like 10 by, I guess 10 by 10. That should be fine. Then we can go ahead and position this at like 5 by 5 by 5. Should work. All right. Then we're going to go ahead and okay, so it is looping. We're going to go ahead and turn on pre-warm. And then start lifetime of 5 is okay. I don't know. We'll give them a start lifetime of 3. We're going to also decrease the rate over time to be like 5. We're going to shrink our size by 0.25. Which I guess actually is going to be up here. So let's go to 0.5. 0.25. That might be a little too small. We'll go to 0.5, I guess. All right, that seems okay. We might go ahead and shrink this down to like. That's probably a bit too much. Let's see, start size, randomized rotation, start color, gravity modifier, simulation space is local, simulation speed local. Body play on awake. That's fine for now. Here we are. Simulate differently each time the effect is played. Okay, so we're going to turn that off, and I'm going to give these all the exact same seed, and we'll see if we can set this up. Actually, I'm going to grab my Woods layout test script here. I'm going to add a script called sync random seed test. Basically what this is going to do is it's going to grab the random seed from one particle system and apply it to another. That way they have the same random seeds, which means that in theory, for throughout the rest of their lifetime, they should have the exact same seeds, in theory. Because as it turns out, random seeds aren't, or randomness is not actually random in these things. There are very specific algorithms, which means that in theory, setting the random seed once should basically force them to be the same forever, in theory. Okay, are we happy with our fog effects there for now? Yeah, sure. Actually, I'm probably going to change this a little bit. I'm going to change this to 20% and make this 80%. Whoa, what is going on here? Okay, let's delete you, I guess. There we go. Make you 80%. Just that our fade in, fade out is a little bit slower. I might also increase this to 4, decrease that to 2. I will also... I'm actually going to shrink this down to 5. And we're going to move this to 2.5. That way, most of our fog effect is contained to the ground and not so much the sky. Alright. So I'm going to go ahead and stop this. I'm going to select my sync random seed test. We'll give this, let's see, a public particle system array systems to new particle system 0. We'll give it a public int seed is equal to 0, I guess. I don't... Darn. I had added a random seed attribute at work, I think. Or randomize attribute. But sadly, I don't have that here. Although we might add one because it could be useful. Do I really not have a randomize? Here, actually, I guess the best thing would be custom editor utility. Yeah, I got a randomize float field and a randomize int field, I guess. Okay, where are you being done? Custom editor utility. Alright. So I have them, but I'm not actually using them, I guess. Well, that's fair. Alright, I might make a quick attribute for that then. Might as well. So we're going to go up to Sleepy Allsoft, common, attributes. Of course, I right-clicked right as it finished compiling, so I'm going to take a drink. Alright. And with that, we're going to go ahead and say... where should I put this? I guess fields? Oh man, really? Of course. Whatever, fields. Go ahead and create folder, randomize, create C# script. I'm just going to call this randomize random int, well, random int attribute, I guess. Seems as good of a thing as any, I guess. We're going to go ahead and open that up. Alright. We're going to derive this from property attribute. public random int attribute. Say attribute to display a randomize button. Well, attribute that will show a button next to an int field to randomize the int value. And that will randomize the int value when clicked. There we go, much better. We're just going to go ahead and copy that and paste that down here, go to there. All right. Then real quick, let's run over here to editor. We're going to add attributes, field. Right, that's what I wanted. Right. I'm going to create a folder. I'm going to call random. I didn't want to call it randomize. I should have just called it random. We'll give this a second, and then it should hopefully finish compiling. I just know that you're gonna do it. You're gonna make me create it, and then of course, random. Yep, there it is. Int attribute drawer. Well, I'll finish typing it, and then it's gonna complain. Random int attribute drawer. Oop. Yep. Okay, spelled that right. We're gonna open that up. So we got common editor using sleepyowl.common. Oops. Gotta go up here using Unity editor. Custom editor. Oh, sorry, not custom editor. Custom property drawer. Type of random int attribute. All right, and this is going to be a. I guess we'll make it an SOS property drawer. We're just going to say override on GUI. We don't need to override the get property height because it's going to be one line. All right, so on GUI, we're going to go ahead and just say custom editor utility.draw randomize int field, and then will you give me, yep, nice property. So we'll say position and then property, and I suppose we'll be fine without the label part. That's fine. We'll actually go ahead and expose some of this stuff over here. So I want to be able to expose the random range as well as the message and the let's see, what are my options here? So I need the min, the max, the label, and the width of the button, I guess. So we're going to say public read-only int min is equal to negative, it'll be int dot negative infinity, or I guess min value. Okay, and then public read-only int max is equal to int dot max value. Public read-only string button label is equal to randomize public read-only float button width is equal to 60f by default. Okay. Which means that I'm just going to do this real quick. It's basically going to be all the same things. All right, and then we're going to go ahead and say, so we're going to have one that's basically empty like that, and that'll have all the default values, and then we'll have one that has all full control over that, so we can specify things if we want to. Let's just go ahead and copy this. And then we're going to say int min, int max, string label, button label, and then float button width. Okay, so this is going to be, instead of all of these things, we're going to say this dot min is equal to min is equal to max. I know it's going to complain, don't worry. We'll fix that in a second. And then we're just going to append this onto everything. Boom, boom, boom. Pretty straightforward. Let's go ahead and comment these real quick. Trying to comment these more. So we'll say min value for the random range of possible values. There we go, for the range of max value, for the range of possible values. Text to display on the randomize button. On the button that randomizes the value, and we'll say width of the button that randomizes the value. Pretty straightforward. Let's go ahead and copy this. I'm going to go ahead and add some quick comments to these, just because it's generally good for me to do that. I started to fall onto the side of over-commenting when it comes to things like this, mostly because these are utility classes that are meant to make my life easier, and if I don't come back to these for, like a year, I'll forget what everything is. So it's good to, just in general, have these things be commented. Custom property drawer for C random int attribute. Okay. And then we're just going to have a quick private random int attribute attr is equal to null. And private random int attribute attr get return attr dot, sorry, not equal null, question mark, attr, else attr is equal to attribute as random int attribute. Okay, and then I can go ahead and just say attr dot min, attr dot max, attr dot button label, and then attr dot button width. Okay, pretty straightforward. So now I can go back to this. We can just apply a random int value there. We'll just leave it as the default. See what that looks like. I'll probably end up changing that to random seed, but this is, for now, this is just a test, obviously. All right. So we have our particle system. I'm going to go ahead and stop this, and then I'm going to duplicate it, move this one over to here. We'll go ahead and call that seriously. How does that even make sense? Particle system. Let's go ahead and just assign our test here, which is going to be way all the way down there. And it's compiled. So, all right. Should it so choose. All right. We're going to go ahead and scroll all the way down here. Where's my testing? It's somewhere around here. This is probably the easiest way to do it. All right. I'm just going to put this on the quad. Wrong thing. Hold on. Test. There we go. So sync random seed test. I'm going to go ahead and put both of these particle systems in there. Go ahead and stop this one. I'm going to move you to be 5. We're going to stop you. All right. Randomize. Clearly 60 is too short for that, which is interesting. So I'm going to come over to here. I guess we'll bump that up to 70 or 70. Let's just see what that does. So you can see that randomize is kind of being cut off here. Oh, nice. I gave it a tooltip too that shows you what the range is. That is nice. All right, we'll give that a second, and then we can, once that goes through, any day now. There we go. Dang it, I was right. So it probably needs to be 80, not 90, 80. Which to me makes this much more like that. Oh, it's because it was refresh. That makes more sense. For some reason, I just thought it was randomized, but sure. Sure. Let's just see what that does. In any case, I can show you what this does real quick by clicking on it. You can see that it's just randomly applying a value. That's all we really need it to do. It's just a nice way to randomly generate a value without having to just kind of mash your hands across the keyboard, which is not particularly great when it comes to random values because there's always bias in how humans do that, actually. All right, so pretty straightforward there. I'm going to, I should have written this in here, but of course I didn't. I'll say private void start. I'm just going to say for int I equals 0, I is less than systems dot length I plus plus. I'm going to say systems of I dot seed RU, something I can do. Oh, it's a uint too. Okay. So that means that it has to be a positive value. Override the random seed used for the particle system emission. So I'm going to kind of cheat this then. I'm just going to say, so we'll say int, we're not going to say int dot min, we're going to say 0 and then int dot max. It's basically half of what a uint can do, which is fine. I guess button label will be generate seed. Terrible. How about reseed? That's better. Reseed. And then a button width of 60. Yeah, 60 should be fine. Okay. I'm also going to go ahead and say, so seed is going to be equal to seed. I hope that that will convert. Okay, we'll just cast it. Uint. All right. And then we'll say systems of I.play. Pretty straightforward. Do you have a delay? Is that what that is? Oh, it's with children, which we don't care about. Okay, so in theory, this should allow me to set the seed of each particle system manually and then play them. However, before I do anything else, I am going to go back to this real quick. Go to definition. I'm just going to set these up to be a default value. So I'll set this up as like refresh, and this will be 60 and 60 again by default. Makes more sense. Should make it a little bit easier when I want to do this. So now I won't really need to, like I don't need to specify 60F if I don't want to. I can just do that. I always like cutting down when I don't have to do things. All right, so we're going to let that go real quick. The value that I have in that seed will work because it's positive, which means that it's going to be within the range of that uint. Unsigned integers are basically have the same numerical range in the sense of like number of numbers that they have. It's just that uints don't go below 0, whereas integers, regular integers, split half of their values between their negatives and positive values. So you can think of a uint as basically an integer that's been shifted by about half of its total values upwards. All right. So in theory, this should make them look the same. I'm hoping anyway. It's possible that it's going to that the randomize algorithm that Unity uses is going to throw a hitch in that. But if we're lucky, it will look exactly the same on both of them. It is really hard to tell, but I think it is. It is. Nice. Yes. Okay. I'm also just gonna... There, this will make that easier. So it's a little hard to tell, but it does look like everything is the exact same seed, which means that all we really need to do to ensure that our fog syncs up is whenever we spawn a section, we need to have that section have its own particle system, and then we need to manually set the seed on that particle system to be whatever the random seed is on another particle system that exists. And then they should be exactly the same. Everything should look the same. Shouldn't matter. We should be fine. To test that, however, I am going to change our test thing here. So we're going to say public particle system secondary systems is equal to new particle system, blah, blah, blah. All right. So we're just going to say private void update. Okay. And then I'm just going to come up to here and we're going to say private void start secondary systems is equal to new. Oops, sorry, it's not equal to new. This is a function, not a variable. All right. So we're just going to say if input.getKey down, we'll just say keycode.m. I don't use m for anything. That should work. We'll say start secondary systems. And all this is going to do is just basically do this same for loop, and we're just going to say instead of systems, it's going to be secondary systems, blah, blah, blah. And it's not going to be random seed is equal to the seed. It's going to be as equal to systems of 0 dot random seed. That should force it all to update the way we would expect. Turn you off and minimize you. All right. Gotta stretch. Okay. So let's go ahead and set this to be 1. We're basically just going to move the secondary one, or the one on the right, over to be the secondary system. The one on the left is going to be our primary system. So let's go ahead and save that and hit play. Both of them should be set up to pre-warm, so they should just instantly function for the most part. All right. Huh? Why? Oh, that's problematic. That might have been giving me false positives, actually. I don't want these to play on awake. For that, I'm kind of a little spooked now, so I'm going to real quick make sure that these function as expected before we do anything else. Also, that's somewhat problematic, but I think we'll be okay. It just means that I have to be sure to call stop on the particle system when we are finished with the... Yeah, okay. That looks good. Everything seems to be the same. So now we can go over to here, move our particle system over to here, make this 1, and let's try this again. All right, so we should spawn in. When we hit M, hopefully the particle system on the right will instantly start playing at the exact same seed as the left one. Okay. No. It's different. Perhaps I shouldn't pre-warm them. I'm going to turn off pre-warm. See if that can help. Turn off pre-warm there. See if pre-warming is what was throwing me off. I'm hoping that was not the case. I'm really just hoping that I don't have to manually do this. Worst case scenario, I suppose that I could have a single particle system that's below the stage, and basically I can just grab particle positions from it and force particles in all other sections. No. No. It's all wrong. Yeah. Yep. They're different. Ah, dang it. They're close to being the same, but no, they're different. Close is not good enough. It has to be exactly the same. That's unfortunate. So, boo. All right. Well, that's a shame. Is there not a way I can force that? We set it to match our. No, I can't do that. I guess let's see what other values we have here. Just want to say secondary systems of I dot seed. No. All right. So we'll go to secondary systems dot I dot particles. So we can get particles. Particle count. Set particles. Will that work? I suppose we can try it. So let's go ahead and say, so instead of start secondary systems, oh man, no way. I'm not going to have to do that in update. That would be terrible, right? So we're going to say systems of 0 dot get particles. Why? Oh, it's because I called you system. Systems of 0 dot get particles. And I'm assuming I've not actually used this before, so let's look some stuff up. All right, so we're going to say unity get particles. All right. So yes, that is an array. That just gets populated. This method is allocation free as long as the input particles array is pre-allocated once. It only gets the particles that are currently alive in the particle system, what's called, so it may only get a small part of the particles array. That's fine, I think. So you get particles. Okay. That's not particularly great. Okay. Set particles. Setting the lifetime of a particle to a negative value or letting the particle being removed from the particle system. In theory, this should work, I guess. So instead of having each thing emit, we would just have them constantly do get particles. That doesn't seem particularly great. All right. Okay, I guess we'll do this. So we're gonna go ahead and come down here and say private particle system particle. Right, like that's what it gives me. Yep. We'll call this control particles is equal to new whatever of 0. We'll do this on start. We'll say control particles is equal to new particle with systems of 0 dot max particles. It's all fine. Right, you moved you to the main, didn't you? Dot main dot max particles. Okay. From there, I mean, I guess. Let's try this then. So when we do this, we'll say get particles and we'll pass in control particles. Okay, I guess this is going to be an int. Count is equal to that. I guess we can go ahead and do this. And I don't know if I want to play or not, honestly. But we'll try it. So we'll say secondary. Yeah, we'll try calling play first. So we'll say secondary systems of I dot set particles, and it's going to be control particles followed by count. Okay. And all we're going to do here is 1. I'm going to shrink my max particle count down here to like 100. 100. Honestly, we can probably go less than that. And then basically I'm going to duplicate one more particle system and I'm going to put it down below everything else, and it's just going to be the control particle system. Alright, so we're going to duplicate you, put you down here. I'm going to call you the control system. We'll put you below this quad. I'm going to 0 this position out. Oh, how terrible. Alright, fine. I guess we're just going to put you there. So I'm just going to put this below this, and go to our quad. Duplicate this, make this be one of them. And then our control system is going to be that. So let's go ahead and stop all of these things. Hit save. All right. Let's try this then. I don't know how well this is going to go, but I'm hopeful. Holy crap, that might have worked. Nope, that might not have. This is a false test, actually. Hold on. I need to compare them with the bottom, which is very difficult to do. I think they are different. So the top two are correct, but that's because they have the same random seed and they started at the same time. They are clearly different from the starting one, though. Yep. Darn it. Well, are they? Yes. Yes. I guess the way we can look at that is, all right. So you've got like a cluster of fogs at the bottom right, kind of. And yeah, we don't have those at the top. So that is not good enough. Can I force them to emit? I thought I had an emit thing. Okay. I suppose I can try moving this up, down here. Let's see how that looks. Maybe if I set the particles first and then call play, maybe that will work. Let's find out. In the meanwhile, we're going to be Unity sync particle system. I should have guessed that multiplayer would show up in here. This is kind of what I need, though. Let's see. Only cares from random ranges or random seed. If the particles that look like shadows are a duplicate of the particles in the air, but both, okay, sure, why not? So I think it's basically doing the exact same thing that I'm doing. Particle seed is equal to that. So I mean, that's essentially what I was doing already, actually. I wonder if he's just ignoring that error that showed up. It's also possible that we can ignore that error, and if that's the case, we'll figure something out there. I would just prefer to do this in a way that does not throw errors to the console, if at all possible. Nope. It's different. All right. Well, let's, I guess, well, let's just do it like this, I guess. I'm trying to think, how do we want to handle this? Because this won't really change much. Okay. Let me think. So we can get rid of this part because that's not actually helping. And probably get rid of you. That's not actually helping. Which one can get rid of you? I'm not sure what I kind of wonder if this isn't the seed anymore. So we might need to do like systems of 0 dot main dot seed. Do I not have that? Okay. All right. That's not really helpful here. We'll let that compile, and then let's see if we can find anything else. Don't need the space there. I don't want network. Yeah, it's not really. Particle synchronization test might be promising, but I'm going to assume that that's not quite what I want. We're going to come back to here. I'm going to click on you. I'm going to put you here, put you there. All right, let's see what this does. We've already looked at this, so it should be the same basically. But once we get both of them playing, I'm going to pause and take a detailed look at them. Because it could be that there is a value that's there, and I just don't have public access to it. Nope, they're both different. Yeah, okay. All right, so let's go ahead and go into debug mode. T, what the frig is T? Oh, that's the total time it's been playing, is it? Well, no, that doesn't really make sense. They have the same random seed, but they're diverging. It must mean that the randomization after the initial random seed is based on something else. Initial module, shape module, emission module, burst size module, curves, rotation module. I don't really see anything that would make perfect sense. Trigger module, submodule, custom data module. No, I don't really need custom data baked into my particles. So frack. It's so disappointing. It almost works, but then it doesn't. Oh, I wonder. Um, oh man, that's a bad idea though. Let's try it. Okay. I'm going to try stopping each system when we start the secondary systems, and then starting them again with the same random seed. So we're just going to set this back to seed, basically. And basically, all we're going to do is we're just going to... Oh, right, we got to cast that. So we're just going to cast this. So we're going to grab this. We're going to do this. We're going to do that twice, actually. We're going to call stop. Get rid of you. And then I'm going to loop through... I mean, I guess I can just do that in the same for loop. Okay. Let's see if that does it. I'm kind of curious to know if it will. So essentially what we're doing there is we're just ignoring the current seed, and we're basically forcing it to simulate from a specific value. Once we have that, we'll probably not make it a static value, because if we make it static, then it gets super awkward, because people could, in theory, like go back and forth between zones, and that would essentially cause everything to respawn again. So we're going to go ahead and stop this. Come back up to quad. I think we're good here. So let's go ahead and save this. I'm going to hover over this just because I want to make sure. How nice is that? All right. We're going to go ahead and hit play. So we should see the left ones, the left particle system play. And then when we hit M, hopefully they will sync up. There will be a little bit of an odd leftover amount of particles in the previous one, but those should clear fast enough that it won't really matter if we're lucky. Are you? Yes, it worked, but it doesn't like that we set the seed value at runtime. So they're the same. I called stop though, Unity. Why are you complaining? Um, so you can see that things are more or less lining up. It is. Are they? Yes. Okay, they are. It can be a little difficult to tell. But yeah, you can see that for the most part, things do seem to be basically matching. And you're still gonna tell me not to do that? Start secondary system. All right, so even calling stop won't really help. We'll still get that error. How frustrating. So that does what I want, but it won't. It throws an error. Um, let me see if this is a problem. Because if it's not really a problem, then I don't mind throwing uh, a warning catch in there or a disable error catch for it. Let's see. Okay, so this is not really anything. Let's see here. So we're gonna type in unert unity assert fail. Just see if there's a better way of handling this before I brute force this. All three are known issues with bugs. We're planning to get to them soon. Let's see. When playing the actual game, I get the citation failed. Don't sit around and see while playing. I can't switch. My only workaround is to mute the control track and switch to an activation once I'm done previewing the particle. Interesting. So I don't really. So this might just be a thing inside of Unity. Might not really be able to fix it. It seems like it's not causing any problems. However, I really, really don't like doing this. I don't like brute forcing errors like that. Okay. So I'm gonna try. I'm gonna try force clearing this. I'm gonna say false and then this dot stop emitting and clear. I'm gonna see if stop emitting and clear gets the error to clear, basically. If that's the case, it's not acceptable still, but I can come up with a workaround. So. Nope. No, I can't. Well, yes, I can. It's just that it's going to be incredibly imperformant. I would have to support an arbitrary number of spawned particle systems per section, and basically every time you crossed and spawned a new section, um, we would force all of the particle systems to stop playing, gradually fade out, and then we would request a new particle system that would be positioned in the exact same spot, have its random seed set, and have it be played, which is doable. Not great though. I would prefer to have just one static particle system per thing that I can set. Okay, so yeah, it's because the particle system didn't clear, essentially. Great. Then, yes. How vexing. Well, all right, I'm going to try. I'm going to try one more test real quick. And that's basically just going to be me kind of spamming them to restart, and I'm going to see what it looks like. Um, so I'm going to rename this like particle system. No, we'll just call this fog dash woods test. That way we don't have to worry about anything. I'm going to go ahead and put this up in my test section right here. All right. I am going to just delete this, and I guess I'll turn this one off. This quad will no longer have this. I'm going to go ahead and go to sync random seed test. While this is going on, we are going to say, okay, we got a couple of things we need to do here. So we're going to say using, not Unity Engine, system.collections.generic, and then we're going to go ahead and say down here, private list particle system spawned systems. We'll just call this systems. Systems is equal to new. I know that's going to cause problems, but give me a second. We're going to ignore all of these, and we're just going to say public particle system system prefab is equal to 0. It's equal to null. Then we're going to go ahead and just say public transform. We're going to have an array here. Spawn points is equal to new transform of 0. All right. So what we need to do here is, oh, you suck. Okay. Let me see. I don't remember if I pool manager.recycle. Did I add a cooldown on this? I did. All right. So we're just going to go ahead and for systems.count. We'll just call stop on these things. We're just not going to worry about you. And then I'm just going to go ahead and say pool manager.recycle systems of i.gameObject followed by a float delay of like 5 seconds. That should be fine. And then we're going to loop through and we're going to say for each of our spawn points, we're just going to go ahead and say, go ahead and grab this. I'm going to say pool manager.request, and then system prefab followed by spawn points of I followed by new vector 3 5f 2.5f 5f. I believe that was the offset values that we had there, and then quaternion.identity, perfectly fine. Okay, so that's going to be our particle system. So we're just going to say particle system is equal to that, and then we're going to say systems. We'll just say system random seed, and system dot play with a capital P, and then we're just going to say systems dot add system. Okay, pretty straightforward. We are not going to have this anymore. So let's get rid of you. Okay. So I'm just going to keep my update stuff. That's all fine. All right. Oh, and I should probably do this. Systems.clear. Okay. So that should essentially let me spawn in these particle systems at will in these sections. And then it should also support stopping the systems, letting them recycle on their own, and then basically just requesting new systems that will have their seed set. So let's go ahead, let's drag you in. Spawn points are just going to be section grass and section path and right. Let's go ahead and save this, hit play, and see what happens. Okay. So, with that, M. Okay, they are exactly the same. Hitting M again. We're stopping. Those are gradually fading out. Okay. Hitting M again. They all still seem to be the same. Hitting M again. Seems fine. Now I'm going to mash it. Wow, that actually looks fine. I'm going to turn off maximize on play so that we can kind of see everything though. All right. So we're just going to go ahead and say like M. You can see all those extra spawns that we had, but it actually does not flood anything. It all looks fine. All right. So that seems to be okay then. So I guess the way forward for us is basically going to be arbitrarily spawning fog in per section and then recycling it. Well, stopping it, letting it run its course, recycling it, and then basically spawning a new one in its place. That's it. It's not as elegant as I would have liked. I would have preferred to just keep everything in the scene, but it is serviceable, I suppose. So let's try this. Okay. All right. So that means I have to decide how I want to do this. I don't know if I want to have the section. It would probably be easier to have the layout handle that for us rather than having the section do that. So, okay. So I'm going to go ahead and I'm going to turn all of these things off. Control system. Oh, that's right. We can get rid of you. I'm going to turn on my layout again. Hit save, and now we're going to try this out. So I'm going to go to Woods Layout New. Okay. We don't have to worry about cleaning up wrap buffers anymore, by the way. It automatically happens. We're going to go over to, dang it, actually before we handle that, I'm going to let that compile. Please don't change anything. Good. I want to change this folder up here before I forget, because I almost did. So we're going to change this to random instead of randomize. Alright. And now, oh, of course you are. I believe in you, Unity. Alright. So now we can get rid of you. We are going to get rid of this. Alright. So the next thing, you can also get rid of you, and I can probably get rid of a couple of these. Get rid of you, get rid of all of this. Alright, and get rid of you. And get rid of that space. Alright, got rid of quite a few lines. We can get rid of all of these things. We don't really need this. We can straight up get rid of this. I'm actually kind of curious. Woods layout. The old Woods layout was... we can't get a good one because this has preview functionality built into it. I was going to say, I'm pretty sure that the old layout methods were pretty complicated and convoluted compared to what we're doing now, so I'm happy with that. Like, I've definitely gotten rid of a lot of these terrible long for loop lines. Although I guess at the same time, my trade-off there is that I have, well, this has 1, 2, 3. This has a 3 nested for loop. And our newest one, the worst we have is we have 2 for loops nested inside of a for each loop. All right. So yeah, the next thing we need to do is handle fog. So I'm going to go up to here. I am going to add a header section, not a G header section, just a header section. This is going to be fog. We'll go ahead and say serialize field, tooltip, private. Yeah, I suppose we could do it that way. Trying to think about how I want to excuse me, handle the particle system. I probably should use my particle manager. So I'll make this an int fog particle ID is equal to 0. We will also make this a particle ID. And then we're going to say ID for the particle system to spawn for fog in each section. Okay. And then I'm going to go ahead and say serialize field, tooltip, private, vector 3. This will be fog offset. It's going to be, like I specified, I think by default we're going to go for 5F, 2.5F, and 5F again. And this is going to be offset to position the fog particles systems at below each section. Okay. Oh, and that means I need to keep track of particle systems per section, which means another dictionary of dictionaries. Go figure. Oh man, go figure. Let's see here. So current collection. We doing anything with you? Not really. Current section index. We doing anything with you? No, that's fine. We'll get rid of you. Inhabited sections. That I think we're doing. Spawn sections we're definitely doing something with. Wrap buffer, we doing anything with you? No. Wrap targets, we doing anything with you? No. How nice. I've managed to, well, mm, yeah, we'll comment it out for now. I don't think we'll need these in the long run, but we have managed to, as of right now, gotten rid of a couple of our old data collections that we had to keep track of, so that's nice. Next, I'm gonna go ahead and I'm actually gonna comment some stuff real quick. This is gonna be sections fog. So it's gonna be a private dictionary. Oops. Dictionary with Woods layout collection ID. It's basically going to be the exact same, except instead of a section, it's going to be a particle system. And then we're going to say dictionary of vector2 ints and particle controller. Particle manager. I forget what I did here. Peak particle data collection. Particle data. Particle instance. Get particle system IDs. Particle IDs. Particle names. Particle root system. There we go. Particle root system. Particle subsystem. That's what I called them all. Okay. It's been a while since I've looked at this. Particle root system. And that's pretty much all we want. So we want to say fog systems, I guess, is equal to new dictionary, blah, blah, blah. So this gets a little bit more complicated, I think. Jeez. I'm not really sure how we want to handle this. I suppose it will be fine to do it the way I was already doing it. Yeah, okay, fine. Well, actually, no. I'm gonna try to clean them up a little bit better. So I'm gonna say private list particle root system. So these are going to be fog systems. I guess this can be renamed as section fog systems. And this is just going to be fog systems is equal to new. This is a list of all of our fog systems. That way, at the very end, when we want to do a brute force cleanup of everything, I can just say, go ahead and clean these things up. That should work. I'm not going to use the delayed recycling method that we used in the test, because with the particle root systems, I can actually, I'm going to do, so particle root system, so fog systems of 0 dot stop, and then, oh no, I thought I could, dot on stop. Okay, I might have to add callbacks to that then. Ha! How wonderful. Yeah. Okay. So if I go to stop here, go to definition, say stop true, stop behavior, with subsystem stop on stop.evoke. With subsystems. Not invoke. That's a little rough. I probably should do that then. I thought I had a thing. Excuse me. Is alive. I could probably add support for a callback here. Actually, no, that's not necessary. That's why I didn't have the callback, because the particle system itself will keep track of it. So if we go to on stop here, find all references, we actually have a right here on particle stopped. Go to definition in particle manager. It automatically handles recycling it. Or not? Where do you recycle? Huh. I what? Do we not ever recycle this? Hold on. Particle system. That request on stop particle system. Stopped. Really? Huh. Time out then. Um, I need to test something real quick. So I'm just gonna go ahead and come over to here, I guess, and I'm just gonna say public int particle ID particle ID is equal to 0 particle ID, and then I'm just gonna do this. If input dot get key down key code dot p, why not? We'll say particle manager dot, oh right, nothing. We're gonna say game manager dot get particle manager dot play particles, and then particle ID. Oh, come on, work with my followed by just transform. Why not? Okay. And then I guess actually if we let's see, that returns a particle root system. So all I'm going to do here is I'm just going to say private particle root system is equal to null root system is equal to that, and we're just going to say if root system, of course I keep calling it Saitem, is equal to null, then we're going to do this, otherwise we're going to call root system dot stop true, why not, else work with me. There. So that in theory will spawn something. I would like to make sure that it works as we would expect. Because I thought I set up recycling on these things, but maybe I didn't. Hmm. Yeah. I was curious. Alright. So let's see if that is actually the case, if it goes away. I'm going to guess no. Let's go ahead and drag in client, which is under resources. What are my options? Yeah. Sure. Why not? It's good enough for me. Um, we're not going to maximize on play because I want to keep an eye on this. So we should basically see a child get spawned under the quad, and then it should stop. And if I'm correct and somehow I'm just missing it, it should recycle properly. If not, we're going to need to build that functionality in. Why did I hit M? That's not what I wanted to do. So I wanted to hit P. All right, and then we're going to hit M or P again. Okay, so we don't actually do anything with it then. How interesting. All right. So we're going to add that, I guess. We're not going to do it in particle subsystem because we don't want the subsystems recycling themselves. We can go down to here. We can go down to here. Let's go to find all references, particle root system. I'm going to need to be using system.collections. Do that. I am going to also, I guess, just come back down here. I'm going to go to stop, which I, of course, did. Yeah, that's fine. So we're going to need to do this. Oof, okay. Yep, okay. So using system.collections. So I have to come down here. I'm going to say private. No, I'm sorry, not private. Protected IEnumerator. And this is actually going to be virtual IEnumerator. Stop coroutine. System.action callback. Okay. And we're going to basically add this to several things. So we're going to do comma is equal to null. I'm just going to copy that and add that to a bunch of these stop functions. Oh, I guess I only have the two for this one. Particles.stop, and then yep. Start coroutine, stop coroutine, callback. I'm just going to go ahead and copy this, paste this. And here we're just going to say while is alive, yield return null, and then if callback does not equal null, callback.invoke. Pretty straightforward. Then we're going to jump over to particle root system. We are going to need to grab these things. I will be putting these to everything. Stop. Alright, so this is going to call back. I'm just going to add that to everything. Call back. Base.stop. Callback. That is all we really need to do there. And then callback there. Okay, so the last thing we need to do is we need to come down here and say override stop coroutine. So instead of doing that, we're gonna do another while loop, but actually we're gonna say, you know what? Actually, I don't even need to do that because I was just gonna call while is alive on every subsystem, but is alive on the root system already does that. So fine. So that should be all we need to do. That means that we now support callbacks. And I suppose that means that once we I'm not a fan of that. Okay. So we're going to go to the particle manager, which is somewhere around here. Oh, yeah, fine. So we need to add system.action callback and then system.action callback. Okay, so we're all good there. The last thing that I need to do here to get things working is we need to find all references. Particle manager. Find you. Actually, no. We need to go to particle subsystem. And basically, particle root system is actually what it is. So on stop, we basically don't want to call on stop in stop. We actually want to call on stop in the coroutine. So I lied. We do want to. We want to do our coroutine. Say override stop coroutine. So we're basically going to do that. You know what? I'll just rewrite it from scratch. Honestly. Yes, I know you're not going to really do much here. Yeah, I think we're good there. Let's go ahead and grab this. So we're just going to do that, basically. Pretty straightforward. Don't think we really need to do anything else. So we should be good. I am going to move this over to here, I guess. Okay. So we should be good. You tried to add system. I don't like it when you add system. And that means something down here. I see. System.action. I don't know why, but I just don't like having... I don't like using system. Or I don't like making that declaration. I just find it much better to use system.whatever. Mostly because system has a fair amount of similarly named classes to Unity, and then things get kind of confused sometimes. So I typically try to avoid the system assembly target. Unless I'm working with a lot of stuff in system, then it's not too bad, but typically I try to avoid it. All right, so let's try this again. And now, I still haven't done it right. Particle manager needs to come down here. Get particles, play particles, system.play, position, parent, return system. I'm sorry, where is this assigned? Get particles. Okay. Oh, that's what that does. Okay, yeah. So we're gonna go ahead and subtract from that. And at the end here, I'm just gonna go ahead and say particles.recycle. So pool manager.recycle particles.gameObject. Okay. And real quick, I want to make sure these are using okay, good. So that should handle recycling particle systems now when we tell them to stop. So let's let that compile, and we'll see what happens. And then I think we'll probably call it a night there, but we do have. Sorry, headset. Um, so we have the groundwork laid for spawning our particle systems, and we know how to get these things working. In the sense that we now know how to enforce. Oh yeah, I should still be able to test this. So we know how to enforce uh, syncing up our particle systems. Actually, you know what? It shouldn't take us really that long to do this. So, particle here. Stop. There you go. Aw. Darn it. Oh, wow. That's a bit of a. I probably shouldn't call it stop coroutine, should I? I should probably call this like stop particles coroutine. It's a little bit better. You are problematic. Why did you do that? Sync random seed test update particle root system 174 subsystem 67 174 174 particle root system 174 right yeah particle root system 174 call oh that's why duh because my code was stupid. I thought of this after I told it. I know what happened. Basically, I forgot to set the existing reference to a root to be null. So when I called m again, it said, "Oh, well, you still have a reference. I'm going to call stop on that." But I should not have done that. So let's go over here to the quad. Stop it. Let me select what I want. All right, sync random seed test. Let's open this up. Basically, I just need to do this. Do. Root system is equal to null. Very, very basic. That was my problem. So I just want to make sure that this properly follows through, and I can spawn and despawn them at will. So it shouldn't actually take too long for us to implement this into our system. I don't think. Maybe I can do that tonight on air. So let's go ahead and hit play here. And then one day we will be able to play. Okay, so we're going to go ahead and just say P. There's our fires. Hit P again, that stops them. P again. All right, nice. So now that is properly cleaning up. Good for us. Okay. So I think we're going to call it a night there. I'm going to look into getting the fog spawning in the rest of the sections, though. So we have the groundwork laid for spawning spawning fog in each section. We do have to spawn it, and we have to despawn it as we're using it. Otherwise, it will throw errors. So that's a little unfortunate that we can't just have like a single static particle system per thing or per section, but I guess that saves me the effort of having to go through all of those sections and add particle systems to them. So it'll be a little bit easier in the long run, I suppose. But I gotta stretch. Okay. So we have the groundwork laid. We should be able to move pretty quickly on actually implementing fog as a synchronized event, and then we should be able to see if it looks correct when we teleport. from what we've seen, it seems like that will be the case. And that was pretty much the last environmental hurdle, I think, when it comes to the woods layout. So we'll have a brand new woods layout finished up that actually supports fog. Yeah, the old system didn't even do that. And then, yeah, we should be pretty good. So, yeah. All right, so as always, I want to thank you all very much for watching, and I will see you all next time.